Hello students, welcome to Vishrut Academy YouTube channel. In previous session I have discussed about relations. In this session I am going to discuss on functions. If you people want to check the session of relations, please go to playlist and go through that. Okay, next, what is function? A relation f is from A to B is said to be function if every element of set A has one and only one image in set B. Let us consider a function A from B, A to B, from A to B, where set A is of containing children, set B is containing mothers. More than one or more children can have only one mother, but no one child can have two mothers, right? No one child can have two mothers, right? Such type of relation is known as function. Next, this is the simplest easy trick to remember like this. Next, real valued function f is from A to real number mapped from any set to a real number or a subset of a real number is known as real valued function. Next, some functions and their graphs. Identity function f is from R to R, y is equal to f of x equal to x, where whatever the input x value you will going to put, you will going to get the same value as y. Therefore, domain of the identity function is R and range also R. In these types of functions, you should remember all this. That is, what will be the domain and what will be the range for the different types of functions, which will be helpful in your CET. Next, constant function f is from R to R, y is equal to f of x equal to c. Whatever the x value you put, the y will be always mapped to c. Y will get the value as c. Therefore, domain is R, that is real number, range will be a constant c. Next, polynomial function f is from R to R, y is equal to f of x, a0 plus a1x plus a2x square plus so on for all a1, a2, a3 so on belongs to R. Next, rational function f of x by g of x, where f of x and g of x are polynomial function where the denominator g of x should not be equal to 0. If it becomes 0, then the given function becomes invalid or tends to infinity, which cannot be defined. It will be not be well defined. Therefore, g of x, the denominator should not be equal to 0. Here for polynomial function and rational function, domain and range differs and depends upon the expression of the f of x and g of x. So, according to example, the range and domain of these functions changes. Okay. Next comes modulus function f is from R to R defined by f of x is equal to modulus of x or absolute value of x. Domain. So, if we consider a function here, it is a graph. Whatever the x value here, f of x is equal to x when x is greater than or equal to 0 and f of x is equal to minus x when x is less than 0, which is important. This is the defined way of the function, modulus function. If we consider a positive value or equal to 0, the function takes same value. If we take a negative value which is less than 0, means negative values, less than 0 means minus 1, minus 2, then we have to multiply minus with that, then it becomes positive. Therefore, the domain is real number, but range is from 0 to infinity. Here 0 is also included, so closed bracket, but for infinity always we should place open brace because it is not there is no end point, it will be going so on. Therefore, we have to end it with open bracket or common bracket. Next, signum function f is from R to R defined by f of x is equal to 1, 0, minus 1 when it is 1 if x is greater than 0, when 0 when x equal to 0. If x is less than 0, then it is minus 1. Therefore, this is the following graph of signum function and it is defined as f of x is equal to mod x divided by x when x is not equal to 0. If it is equal to 0, then x value, f of function value also becomes 0. So, this is the particular graph. Here we can see for 0, it is mapped to 0 only. Leaving 0, the other values takes, if it is positive 1, if it is negative minus 1. Therefore, range will be minus 1, 0, 1 and the domain will be real numbers. Next, greatest integer function f is from R to R defined by f of x is equal to greatest integer of x where x belongs to R. If they give any number, you should round off it to a greatest positive integer. For example, they give you 1.5. It lies between 1 and 2. So, you have to round off it to 1. So, similarly, here you will going to get the domain is R and range is integers. Next comes types of functions. In first function is into function. If f is a function from a non-empty set A to non-empty set B having elements, for example 1, 2, 3, 4, A, B, C, D, E, and here 1 is mapped to A and 2 is mapped to A, 3 is mapped to B, 4 is mapped to C, then D and E are left here. If any one element present in a codomain is not mapped, then we say that that function is into function. Next comes onto function. Let us consider the elements of the set A is 1, 2, 3, 4 and for set B is A, B, C. 1 is mapped to A and B is mapped to 2 is mapped to B, 3 is mapped to C and 4 is mapped to C. In the codomain, if the no element is present, that is the in onto function, the domain, the codomain and the range both are same. The whole codomain itself is mapped. Then we say that the given function is onto function. Next comes one function. The name itself is saying that the every element is mapped to single element. One element mapped to one element. That is 1 is mapped to B, then 2 cannot map to B. It should be mapped single like this. This type of function is known as 1, 1. This is graphical representation of 1, 1 and onto. But mathematically, you know how to solve it. In the theory sessions, we have done that. If they are given, for example, f of x is equal to y be a function, then how to check 1, 1? Let us consider x1, x2 belongs to a set A. Then f of x1 is equal to f of x2. On simplifying, we should get x1 is equal to x2. If we get this point, then it is 1, 1. Otherwise, it is not 1, 1. What about onto? In order to check onto, what you will do? Let y belongs to f of x. That is, in terms of x you will going to define, that is g of y. Okay. After that, you will going to check whether all the y is mapped or not. Then you will say that this is onto. Yes. Next, since this is for CET, just briefly I am going to explain, not detailed explanation is needed. Next, many one function. The name itself is indicating 1, 2, 3, 4 and A, B. If any elements map to, many elements are mapped to only one element of B, then we say that it is a many one function. Or even you can take like this also. This is also many one function. Next, bijective. Bijective function is the function which is 1, 1 and onto. 1, 1, it should be 1, 1 also, onto also. Then how you can write? If A, B, C, D, 1, 2, 3, 4, every element has its pre-image. In this function, every elements in set B should have pre-image. Then only it can become onto, right? And what about 1, 1? Every single element should be mapped to only one element. No other element should be mapped to this. Then we say that it is bijective. Next, inverse of an element. For example, take here f of A is equal to 3, right? And f of B is equal to 1. And f of C is equal to 2. And f of D is equal to 1, right? By this example, I took these values, okay? In order to write inverse of an element, what you should write? F inverse of 3. That is, the inverse of the 3 is mapped from what element? A. So, that is the answer. So, F inverse of 1 is B. F inverse of C is, F inverse of 2 is C. F inverse of 1 is D. So like this you should map. F inverse of 4 is D. Next, invertible function. When we say that given function is invertible, if and only if f is invertible, then it should be 1, 1 and onto. If conversely, if f is 1, 1 and onto, then it should be invertible. So in order to prove invertible function, if we prove it is 1, 1 and onto or it is bijective, then it is nothing but invertible function. That is, if f is a mapping from A to set B, then G is called invertible function which is mapped from B to A. Okay. Please take screenshot of this so that it will be helpful for you people. Which is most important in CET problems, you will going to use these formulas. See here, if let f is a function from A to B, number of elements in the domain set A, in domain set or first set, that is A is equal to m elements, and number of elements in codomain or a second set B is n elements, then how many number of onto functions are possible? We can, how many numbers of onto 1 bijective functions can be written, or total number of functions how many you can construct. Let us check. First, in first case, if m is greater than 1, total number of functions you can write n raised to m, and 1 function, since m is greater than n, so therefore 0. Next, summation r equal to 1 to n minus 1 raised to n minus r, NCR r raised to m. Next, bijective function, since 1 is not present, means automatically bijective cannot be defined. Next, if m is less than n, if m is less than n, then total number of function here also n raised to m, but 1 function is npm. Onto function will be no onto function, because here m is less than n and there is no possibility of bijective also. Next, if m is equal to n, then we can write total number of functions in n raised to n ways or m raised to m, and 1 function n factorial or m factorial, onto functions n factorial or m factorial. Similarly for bijective also n factorial or m factorial. Next comes algebra of a function. If f and g are two functions, then f plus g of x, algebras, let us discuss all the basic fundamental operations. That is, f plus g of x is equal to f of x plus g of x. Next, f minus g of x is equal to f of x minus g of x. Next, f into g of x is equal to f of x into g of x. And this last one, f by g of x is equal to f of x by g of x, provided here g of x should not be equal to 0. Okay, these are all the algebras of a given two functions. You can construct them like this. Next comes composite function. Let A, B, C be three non-empty sets such that f is a function defined from set A to set B and g is defined from set B to set C. And if x is an element belongs to set A, then f of x is equal to, will be mapped to set B. Let us consider y, the element y belongs to set B, and let us consider that y belongs to set B, since therefore g of y is equal to z. So we can write z is equal to g of, in place of y, f of x. So such type of function is known as composite function, and it is also written in the form of f dot g of x. This is nothing but f of g of x. Similarly, we can write g dot f of x, which is equal to g of f of x. These two these two definitions are important. If you know these definitions, then you can solve CET questions. Okay. If n of a equal to 5, then total number of relations on set A is. So it is A is related to A itself. If they give like this, it is mapped to itself. So you have to take 2 raised to n of A into n of A. That is 2 raised to 5 into 5. That is 2 raised to 25 is the answer. Okay. Which was asked in Comet K. Next, define a relation R on A is equal to 1, 2, 3, 4 as x is related to y if and only if x divides y, then R is reflexive, transitive, symmetric and transitive equivalence. So here the condition is given that x divides y and the numbers are 1, 2, 3, 4, 1, 2, 3, 4. See here, first of all, in order to check the reflexive, symmetric and transitive, you should know them. If you are not having any clear idea, please check the relation session which is in the playlist. Okay. Next, what is reflexive? X divides y means every element divides itself, right? So it is reflexive. Yes. What about symmetric? Let us check. 1 divides 2, but 2 divides 1. Is it possible? No, it is not possible. So therefore it is not symmetric. What about transitive? 1 divides 2, 2 divides 4, 1 divides 4, 1 divides 2, 2 divides 4, 4 divides 1 divides 4. Of course, 1 divides 2, 2 divides 4 and 1 divides 4. Therefore, it is transitive also, but symmetric fails. Therefore, only reflexive and transitive. Option A is correct. For the set A is equal to 1, 2, 3, define relation R in the set A as follows. R is equal to 1, 1, 2, 2, 3, 3, 1, 3. Then the order pair to be added to R to make it the smallest equivalence relation. The relation is already given. In order to make this equivalence relation, you have to add smallest order pair. Which is that? Just look here. Since the given set is 1, 2, 3, for reflexive, all elements should be in the form of A, A. That is 1, 1, 2, 2, 3, 3. Of course, it is reflexive. Next, what is extra here? 1, 3. If 1, 3 is present, 3, 1 should be present. This is symmetric condition. So, what is missing? 3, 1. Let us take it. That is B. If I take 3, 1, what about transitive? If I think 1, 3 as A, B, 3, 1 as B, C, A, B, B, C, A, C, that is 1, 1 which is already present. Or if I take 3, 1 and 1, 3, 3, 3 which is also present. Therefore, it acts as smallest equivalence relation. Therefore, option B is correct. Well, before starting with problems on functions, I want to give you hints. That is, in order to success in your CET, just brush up your basics which you have already studied in your PUC and go for, you just refer exemplar textbook. That is more than enough, and also solve previous year questions so that it will going to help you a lot in order to success in CET with good scores. The number of functions from A is equal to 1, 2, 3 to B is equal to 4, 6, 8, 10 is 24, 12, 81, 64. I have already given the table C. You just check there. What is given there? If A has m elements and B has n elements, then number of functions is nothing but n raised to m. N of B raised to n of A. That is, what is, how many number of elements are there in B? 4, right? In A, 3 elements, right? 4 cube is 64. The option D is correct. Okay. The number of relation from A is equal to 2, 6 to B is equal to 1, 3, 5, 7 that are not function from A to B. Before we used to find number of functions. Now they are saying not a function. In order to find not function, here you have to consider total number of relations minus number of functions. If we subtract number of functions from a number of relation, we will going to get number of not functions. So number of relation minus number of function. For number of relation and number of function, you have the formula. What is that? For number of relation, 2 raised to n of A into n of B minus for number of function to n of B raised to n of A. See, 2 raised to, what is n of A? How many number of elements are there? 2 into number of B, number of A, B elements 4 minus n of B. What is n of B here? 4. What is n of A? 2. So calculate now. 2 raised to 8 minus 4 4s are 16. 256 minus 16, that is 240. Not a function. Number of functions are 240. So this is the answer.